Hi, we're the Sentinel Capstone team, and today we're going to share our experiences from working on this project all semester. Here's our team. They will all show up at some point in the video, but I'll quickly introduce them. We have Avi, myself, Nestor, Taylor, Josh, Michael, and Steven. I'm Avi. Before we kick things off, we just want to give a big thank you and shout out to our sponsors over at General Dynamics Mission Systems. John, Nick, David, and Eric. They're all engineers, each with their own skill set, from hardware and embedded systems all the way to computer vision. Since the beginning, they have been very friendly and helpful. If any one of us has ever been stuck, they were quick to help us remove any obstacles that may have been in our way, and we thank them very much for that. So why Sentinel? Imagine you are on a mission to rescue a lost hiker trapped in a snowy mountain, an environment very similar to the picture on this slide. There is a problem though. You don't exactly know where the hiker is, and there are many obstacles in your field of view, making it very difficult to see him. This is where Sentinel comes in. Using mixed reality headsets like the Microsoft HoloLens and a DJI drone, we can better equip first responders and military personnel. These headsets, with support from the drone's video feed, will give them a technological advantage to better understand their environment and surroundings by having relevant information portrayed on the lenses of the HoloLens.
Hi, I am Steven Sautel, and I will be presenting on my part now. So recently, a lot of my work I've been doing for the project has been on getting the HoloLens actually working. So what that means is basically we are at the General Dynamics lab, and we need the HoloLens to be working so we can test our feature on it. And it's actually pretty tricky to get that working because you have to connect the computer at the General Dynamics lab to the HoloLens using our student account access. So there was a lot of things to do to get onto the Wi-Fi, and then the Wi-Fi authenticated, and then the HoloLens onto the Wi-Fi. And we had to do some interim stuff with a cell phone hotspot mobile network and things like that. But we have the HoloLens working now. So that's what I've been working on a lot recently. And then other than that, I've been doing a lot of like integration work. So things like getting Python working. I've worked with Michael on that a little bit. And then also kind of getting started a little bit with Nestor as well. Handling how the Unity scenes are getting sent over to HoloLens because they have to be kind of like custom scenes when they are presented. They can't just be like a normal scene. There has to be specific settings tweaked and things like that because HoloLens obviously is going to need some extra work. So that's kind of where I've been at a lot of the time, especially since the last presentation we gave in around the middle of the semester. That's what I've been working on.
Hello, my name is Nestor Casillas, and today I'm going to be presenting what work I contributed to this Capstone Project for General Dynamics. To begin, I helped with the project planning. One of the tools that we first decided to use was Trello, because I had some experience with that previously, and the sponsors also recommended it as well. But they also recommended that we use a Gantt chart, so we ultimately just created a timeline for this project and where we think we would go, even though it's not entirely accurate. The second thing I helped was with the Unity avatar representation. On the screen here, we have a similar avatar to what I used. I tried using Blender initially, but that didn't work out, so I just got something from the asset store. Unity integration. Steven, Michael, and I are trying to display our avatars to the HoloLens, and finally, I also helped with the GPS coordinates with Josh and Taylor. Thanks so much. This is what I contribute. Have a nice day.
Hi, my name is Michael Mediola, and I'll be discussing the modules that I worked on during this past semester while working with the Sentinel Capstone team. So I was tasked with the object recognition module. So what this is we retrieve footage from a drone and we analyze it frame by frame. And as we're doing it, analyzing it frame by frame, we look at the pixels and the pixels colors. So as you look at the left-hand side, you can kind of see how our algorithm works. So our starting point is the blue circle, and as our algorithm progresses, it moves that circle to where the green circle is. Since there's more red pixels in this area, we can see that there's probably an object of some kind of importance there. So in our case, we were looking for red colored pixels, If you look at the right-hand side picture, you can see that our algorithm detected a car, drew a circle around it, and is able to track it right to left. You can tell by the red line tracing the center point. And so that was basically one of the modules that I had to work on. I coded in Python. So next, my next module is pretty much integration of all the modules. So what this is making it easy for all of us to put our code into one file or one solution and combine it without too much trouble, because overall integration takes a while. It's kind of hard when you have multiple different languages. We're using Python, C#, and things like that, so it's a lot to it's a bit tough to combine them all. So my job was to create these preset classes, driver program that is able to access all of these classes that we all made and use them as needed. So making it as easy and simple as possible.
My name is Josh Holt, and this semester on the Sentinel project, I was in charge of leading the efforts for the research and development of the geometry module. Now, the geometry module's purpose is to calculate the GPS coordinates of an object that's been recognized by the machine vision program on the drone. Now, we had two proposed ideas and theories of how to go about solving this problem in the beginning. One, the first method, is very limited in scope, but it's a good mental exercise, and the second one is actually one we decided to use. Now, the first one involves just piloting the drone directly over top of the object in question. This means that the GPS coordinates of the drone and the GPS coordinates of the object are the same. The problem with this is, what if you want to look at an object that is inside of a garage or has some foliage over top? It's not very feasible in many situations, so we had to scrap the idea. The second idea involves using the law of sines and some basic trigonometry to calculate the to calculate the distance in feet from the object to the drone, and using that information, you can calculate the GPS coordinates of the object. As for the module's code itself, I can't really show you that. It's General Dynamics proprietary information. However, we can say that it utilizes the data and some calculations from before, alongside some other programs, to calculate the GPS coordinates of an object and relay it back to the HoloLens so that the user knows exactly where in relation to them that object is. Thank you.
This semester we had 5 different requirements. We had the geometry module, the image recognition module, the GPS code module, the avatar representation, and the object information overlay. For the geometry module, we needed to get the GPS coordinates of the HoloLens user, of the drone, and the identified target. Along with the GPS coordinates for the drone, we needed to get the altitude of the drone along with the gimbal data. With all 3 of the sets of GPS coordinates along with the added altitude, we were able to gather the relative positioning and size of the object to the HoloLens user, along with the distance from the HoloLens user to the object. For the image recognition module, we needed to identify 2 objects, whether it be a car or a person, based off of if the car or the person was wearing all red. Once it was able to detect an object, they were to track it with a moving pixelization to keep track of where the object was moving and where it was last seen. The GPS code module is where we needed to take in real-time coordinates from an Android phone and pull them into our HoloLens users. That way they could see the relative positioning and size. For the avatar representation, we needed to, once we actually identified the objects, place an avatar, whether it be the car or the person, on top of the actual object and portray it red if it were to be an enemy. And for the object information overlay, the HoloLens user was supposed to get the distance to the object, along with what the object was it a car or a person, and where the object was last seen. My contributions this semester were I helped work on the transform equations. This allowed us to get the coordinates and the distance from the HoloLens user to the actual object. I also helped on the multiple object tracking to where it could detect color and pixel within an object, and it would keep tracking depending on where the object moved to. And I helped on the GPS code module and pulling in coordinates from a file.
I also will talk about the rest for next semester. So some of the things we're worried about are we have a lot of stuff on our plate for next semester. So we want to do a lot of things about continuing forward. We kind of have a proof of concept now, and we need to get it working really well. We also are a little bit worried that we just be a little bit unclear on what we need to do. And so we might not get the direction on exactly how the project should go. This has been something that we've always been working on with our sponsors, but because the project is so new, it's hard to kind of always know for sure if we're on the right direction. Our team is also very good at kind of like going with the flow, but I think it's also going to be important for us next semester to start being more structured, especially as the code base gets more and more complex as we keep working on the project. We'll want to make sure that we are, staying together and making sure we're on the same page. Also, burnout. We're all seniors, and it's going to be our second semester, so we have to be aware of the fact that some of us are probably going to be less motivated than we were before, and how we're going to have to handle that. And then finally, of course, there will be unseen issues. So things like medical that could come up. Sometimes people have to drop out of a semester for medical reasons, and so it's hard to anticipate what would happen there. But we're including it there because that's always going to be a risk that you have to take care of. Thank you.
All right. So as the semester comes to an end, speaking personally, and I'm sure it's the same for the rest of the Capstone team, we've learned a lot, dealt with a lot. It's been a wild roller coaster the entire semester, but it's been a fun one. So speaking about this semester, we've accomplished a lot. Coming into this project, none of us knew Python, Unity, or the HoloLens. Some of us have worked a little bit with C#, but overall, we didn't really know much. So we've done a ton of research, learned a lot, and we defeated many of our roadblocks that we came across. Such roadblocks include like dealing with new APIs, new algorithms, integration, all that kind of stuff. Other than that, we got to play with so many cool devices. We got to use the HoloLens for the first time, experience some VR things that General Dynamics provided. Great experience overall, and I'm sure all of us are excited to start next semester and really cracking down and progressing this project even more than it already is. Overall, we all want to give a huge thanks to our sponsors at GD. They've been there the entire semester, giving us support. Whatever we needed, they were there.